Welcome to This Explainer. Today, we're unpacking a massive, fundamental shift happening right now in software development. We're talking about how AI is taking code review, which, let's be honest, used to be a tedious chore or a downright intimidating gauntlet, and transforming it into this incredibly powerful, human-guided craft. So whether you're a student, a junior dev, or a seasoned software architect, figuring out how to navigate this new AI-assisted landscape is absolutely going to define your workflow for years to come. Let's dive right in. We've got a super clear roadmap for today. We'll be looking at the code review philosophy, how AI acts as a disruptor, the core pillars of the process, modern workflows, and finally, learning and responsibility. Starting us off with Section 1, the code review philosophy, a collaborative craft. Historically, especially early in our careers, it's so easy to experience code review as a personal critique, right? We kind of defend our code like it's our own private property. But we really have to shift that mindset. Professional teams don't look at reviews as personal criticism. They embrace them as a shared, highly collaborative practice of quality assurance. The whole point isn't to judge the person who wrote the code. It's about improving a shared artifact as a team, catching those inevitable blind spots and assumptions that just naturally happen when we're writing code under a tight deadline. All right, moving on to Section 2, AI as the disruptor, the new review partner. So what does this actually mean? Well, it's absolutely crucial to understand that an AI-assisted review is not about replacing human developers. No way. Instead, it uses language models and coding agents to instantly surface potential bugs, structural issues, or even missing tests. Because AI is literally built to recognize patterns at lightning speed, we get to spend way less time hunting for obvious things like missing null checks and a lot more time focusing on the big picture. To make this super concrete, just look at how modern tools are actively doing this. We supply the human intent, and then tools like OpenAI's Codex CLI jump in, operating right there locally in your terminal. You just drop a simple /review command, and boom, it acts like a dedicated reviewer for those specific changes, giving you targeted feedback almost instantly. You can even wire this directly into GitHub pull requests for an automated pass. But, and this is a huge catch, while AI gives us incredible speed, we've always got to verify its findings, because it just doesn't have our real-world context. Which brings us perfectly to Section 3, the core pillars. We're talking readability, bugs, and security. Take security, for example. You have to constantly ask yourself guiding questions like, does the change actually check who is allowed to perform an action? Because sure, an AI can spot a syntax error or a missing character in a heartbeat, but it doesn't intuitively know your specific security requirements. It doesn't know your authorization rules or the actual real-world impact if that code happens to fail in production. This brilliantly illustrates the divide between human and machine. AI absolutely excels at catching isolated technical flaws. Missing null checks, duplicate logic, unsanitized strings, it's got that covered. But humans, we are absolutely essential for understanding the actual context. Think about it. A pricing algorithm might be syntactically perfect, it could pass an AI check with flying colors, but it might completely violate the company's core business rules. That's where we come in, assessing real-world business risks, understanding legacy architecture, evaluating architectural fit. That is entirely on us. And beyond just squashing bugs, we've got to talk about readability. Listen, readability is not some aesthetic luxury. It is a hardcore security and maintenance requirement. AI can point out overly complex loops or maybe suggest renaming a variable. But true readability, that's about making the code understandable for the very next human being who has to maintain it. If code is unreadable, it is unmaintainable, and eventually it becomes a massive security risk simply because the next developer won't have a clue what it actually does. When we bring all of this together regarding security, we hit a slightly harsh but totally necessary truth. An AI review result is absolutely not a security certificate. Seriously, treat it as merely a supplementary layer of baseline hygiene. AI systems can hallucinate problems that don't actually exist, or, much worse, completely miss critical vulnerabilities that span across multiple files. So when it comes to security or potential data loss, an AI scan is never a guarantee. It's really just a useful impulse to trigger our own deep human testing. All right, let's look at how this actually plays out day-to-day in Section 4, Modern Workflows, Pull Requests, and Proof. Think of the modern pull request workflow a bit like a sandwich. Step 1 is the human setup. We write the code and clearly state the intent. Step 2 is the AI processing, rapidly scanning the diffs and flagging any missing tests or bugs. Step 3 is the critical human verification, where we check the context and assess the real-world risk. And only then, at step 4, does the team actually merge the pull request. So it's human intent at the start, critical human verification at the end, and AI accelerating that messy middle. Now, how do we actually verify that intent? Well, with tests, of course. Tests in a pull request act as executable proof of expected behavior. An AI might spit out a handy list of missing test cases, but the tests you actually include must serve as tangible proof that your human assumptions about the code are exactly right. Doing a review without tests is basically just guessing that the code works. Tests are what turn abstract requirements into hard, concrete proof. Let's wrap things up with Section 5, Learning and Responsibility, the human element. There is a massive, massive risk that AI poses to our learning process. If developers, especially junior developers, fall into the trap of passive acceptance, just blindly clicking accept on AI fixes without actually understanding the underlying logic, well, they stop learning. They get this illusion of superficial productivity, but it comes at the direct cost of actual competence. We absolutely must prioritize active reflection. We need to use AI hints to question, to test, and to justify our technical choices. AI should be your sparring partner, not your crutch. If you take exactly one thing away from this entire explainer, let it be this. An AI hint is not a verdict. It is a testing impulse. It's a hypothesis. When the AI points something out, it's essentially just raising its hand and saying, hey, you might want to look at this. It is entirely up to you, the human developer, to investigate, test it out, and make the final call. Because at the end of the day, AI does not carry any legal or organizational accountability. If an AI suggestion introduces a massive data leak, the AI doesn't get fired, right? And it doesn't get sued. The organization does. That accountability stays squarely on our shoulders. This is exactly why teams have to carefully define their tool governance. We need clear rules for documenting exactly why critical suggestions are accepted, strict boundaries defining what code the AI is even allowed to see, and a constant, conscious effort to balance rapid deployment speed with deep human code comprehension. So, I'll leave you with this provocative thought to chew on during your very next pull request. When you're scrolling through those AI-generated hints and fixes, ask yourself, do we really understand every accepted AI suggestion? Are you truly acting as the accountable craftsman, verifying and steering the process? Or are you just letting the tool do the driving? Thanks for hanging out for this explainer, and definitely keep that question in mind the next time you're about to hit merge.